All right. So this is Intro to Git. This is a demonstration. It's not a lesson. You don't need to do anything in this. Just watch. You can take notes if you want. I'm going to give you a really high level overview of what Git is, like what the common commands are, and then we'll do like a lesson and play with this a little bit more probably later. So Git is a version control system. So I mentioned it yesterday, but this gets us through the Git. Yeah. This gets us through gets us around the version 1, version 2 final, version 2 final really, that whole problem. Git gives us a way more robust way to handle that. So it is was made probably maybe 15 years ago. Yeah, that sounds about right. I'll bet it's about 15 years old. It was made by a guy named Linus Torvalds, who is known for two things. Linus Torvalds is known as the Linux. He's the Lina in Linux. So that's his project, as well as Git. The other thing he's known for is being like one of the biggest assholes in like all of software. He's a jerk. And he actually like it was kind of a big deal last year because he like went to therapy for the first time and like it made the news. But super abusive asshole. Just mean. But he's gotten a lot better. He took like a year off from the Linux project and took a year off from Git. Went to therapy. He's been a lot nicer since he got back. But it was an interesting piece of trivia about this. So the way that Git was designed to solve version control in a new kind of way, in a distributed kind of way. So we've actually had better solutions than just renaming folders for a while. But all of them were what we call centralized version control systems. So centralized version control. The way that works is all the people on your team.
Kyle, I'm sorry.
Oh, come on,
Are
dude.
you writing stuff?
Of course I am. And I'm not sharing because I'm not. All right. All right. So the other stuff that I had here was just that. All right. So centralized version control. Everybody in your team would have a copy of the code, but every time that they wanted to change something, they would check it out, and nobody else could use it while they had that little part of the code. It didn't even have to be code, just files. You say, I'm working on this file, I'm working on this folder. So they check it out, and when they're done working on it, they check it back in. And so everybody is doing that all the time. Check out, check in. Give me some stuff. Here's my changes. And so you would have like one computer that would just be responsible for keeping the master copy of the code. And then people would work on it that way. Can anybody think of like what the two biggest problems with that were?
Well, it seems like it would take a long time to make changes to the program. Only
Well,
one person at a time can make changes.
no, these three people can make changes at the same time. They can't make changes to the same files at the same time. So if there's 10 files, you can go, I'm checking out these two and editing those, but I can't change any of the other 8 files, but somebody else could be checking out those.
What you do in one code might mess up what somebody else does later on in their code.
Um, oh yeah, it could be like super awkward where you check out a file, you make a change, you put it back, everybody else gets your copy of it and goes, "I'm sorry, why did you do this? Come on, man, I was working on that. You took my Legos apart." Yeah, that still happens with Git, by the way, but there's way better tools for fixing it. What else? What else is like kind of awkward about centralized version control?
One computer, right? That's responsible for the master.
Yep. So what is that? What kind of risk vector do you have there?
So if it fries, like you're done.
That's the code. Bye. Um, so yikes, we don't like that. That's one of the big problems that we need to fix with Git. The other one's a little more subtle. It's that somebody would check out code and then go on vacation. Now nobody on the team can do anything with that code for 2 weeks. um, it was a mess. The most popular one of these, and it's still around some places, and it sort of shows up at companies like Ford more than it tends to show up at companies that are not like Ford. No judgment, just saying. Um, is a tool called SVN. It's like leet speaky kind of thing for subversion, because you can have versions and subversions of your code and stuff. So SVN was probably the dominant one of these. There were a couple of others like Perforce, but then we got distributed version control, and everything got better. So the way that distributed version control works is everybody in your team has a copy of the code, and everybody can work on everything at the same time, and you just share with each other. And so if you change a file and somebody else changes a file, there's an algorithm for figuring out, like, if it's very clear that one of them was intended to supersede the other. Otherwise, you get what's called a merge conflict, and you go, all right, these two lines conflict when I'm trying to sync up between these two people. Which one do you want to use? And then you fix it. But our first issue of like having that one computer, and if that fries, you've lost all of your code. The thing that makes this distributed is that everybody has a complete copy of all of the code and the entire history of that code. So if these two people get hit by a bus, all right, the two team members you hired to replace them, all they need to do is copy this person's Git repo, and they have it all. That's pretty cool. And so if one of these people is Kyle and this person is Blair, this person could be our friend GitHub. GitHub is, it's not a centralized thing. That's not the point of it. The point of GitHub is that it gives us just a person that we all know who has a copy of the code. But it's not more important. Doesn't have any primacy over me or Blair and our copies of the code. We could even have other things like GitHub. Like there's a competing service called Bitbucket by Atlassian. There's another competitor called GitLab. We could be using all three of them. Like, you don't know anything necessarily about your peers, but all of you have a full copy of everything. And when one of you makes a change and you want to get somebody else's changes, you just smash them together. And if that doesn't work, then there's some pretty awesome tools for helping you figure out whose version you want. So Git is a distributed version control system, and it solves our single point of failure with the server just fine. And makes it so that if Blair goes on vacation, me and GitHub are fine. We can keep on going forward. There's also a bunch of other things that I think Git does way better than something like SVN, as far as allowing you to do experiments and have different branches. And some of those things like were features in centralized version control, but they're way better and more robust in Git. Now, trade-off, SVN, as awful as it was at least kind of easy to understand. Git is not. Git is like one of the most obtuse, like just difficult pieces of software I think I've ever come across. And the best way to explain that is xkcd. There's an xkcd for everything. No exception here. That pretty much describes how everybody feels about this. Yep.
This is going to be a dumb question, but GitHub in this sense then is just a storage.
Yep.
Because it'll never make changes. Only you and Blair in this instance would make changes, but you'll
Correct.
copy those files over to GitHub.
You are correct.
Okay.
Yeah, it's like Google Drive, but for code. Cool. Super high level. Difference between centralized version control and distributed. Any questions so far?
I'm guessing by that cartoon, I'm not the only one who's lost whenever you open up Git.
No, it is a very difficult to use program. All right, so last thing I want to do is I want to show you what a Git workflow kind of looks like. And then you can use that as some context as you're going through the readings and exercises and stuff. All right, so projects, practice. I'm going to make a folder called Git Practice. All right, so totally empty folder here. If I make let's say it's like an index.html, and I open it up and put some HTML-y kinds of things. Come on. Doc type. Head. Body. Required parts of an HTML head. Title. And character set. Anybody know what Hello World is? Why you see that so much in all these like intro tutorials?
It's like the first program most people learn to build, isn't it?
It is. Why?
It was the first message that was put out there, wasn't it?
Yeah.
Was it on HTML or it was? Yeah.
It was the first web page. That's what it said. Made by Tim Berners-Lee in 1989, 1990 or so. So, okay, so I've got this index HTML page. Hey, I could even serve it up. Oh, come on, man. There we go. So I serve this up. npx. All right, cool. So I've got my site here. let's say I want to turn this into a Git repository so I can control its versions. I do that with the git init command. It says, hey, you made an empty Git repository, and we see my agnostor terminal picks up on that. The only thing that actually happened here, this is the only file I made. It made this hidden folder called .git that has all of the version control stuff in it. You never need to touch that folder, but that's what a Git repository is. It's just something that has that .git folder. And git init sets all that up for you. So yes.
How do you link that to your specific GitHub, like with your login and all that stuff? Does it matter?
So this is an important distinction. Git is not GitHub. You can use Git completely independently of GitHub, but I'll show you how you do that. If you just wanted to use Git to version control your diary or something like that, you never want it to go on the internet. Like, that's a perfectly valid use of Git. So, all right, I have this empty Git repository. Otherwise, haven't done anything with it. So the first thing that I do is stage a commit. Now, this particular thing really messes with people. There's a little story that I learned once that I think hopefully makes it a little bit clearer. Rocket ship. So we got a rocket ship. It's going to outer space. But we got to load it up with like all the cool stuff first. So out in the dockyard, we've got all these like empty crates. And we've got the stuff that goes in those crates. This is food and batteries and water and all that kind of stuff. So I've got all that over here. What we want to do is pack that into these crates and then load the crates on the rocket ship before it goes off. In computer terms, these are files. This is staging. This is committing. So if I want to stage that index.html file, I add it. So I have loaded that index.html file into the crate. To load it onto the ship, I commit it. Add index.html. And yes, that super weird tense is the correct way to do it. It's a command. You're saying, I command you, add index.html. Or my favorite way I described this really recently is you should be able to put love to in front of it. Like, that's how you get the present imperative tense that you're supposed to use for git commits. All right, so committing it loads it on the rocket ship. The rocket ship has not gone to outer space yet, outer space being GitHub in this case, but I loaded up a file there and I sealed up the crate and loaded it on the rocket. So that's staging, that's committing. And then I can make changes. I can say things like, all right, I want to open up that index.html file and add a greeting. And so like that little plus over in the corner, you installed the plugins for this too in VS Code. It'll tell you like, oh, by the way, this changed since your last commit. And so now my terminal's telling me that like, hey, you've got some stuff that you haven't committed. And I can say, well, what do you mean? And it's saying, well, you modified this file. All right, well, what if I stage the change that I just made and commit that? Love to add greeting. Cool. I could change something. I could say, change something in the title. But I can stage my change, commit it. This is change title. Cool. Hey, I want to see the changes that I've made before. That is the 3 things that I've done in this repo. All right, well, now I got to get it on GitHub. So I head over to GitHub. Tell GitHub I want to make a new repository. Give it some kind of name. And then, oh, all this intimidating. All you got to do is take that URL and cast the magic spell. Magic spell is git remote add origin. And then paste that in. That is how you connect your local repo to Git's remote repo. And then I can say, I would like to send my changes to origin. That's the, think of it like an alias for GitHub in this case. And I want to, I'm on my master branch. I want to push my master branch up there. So I do that. And when I refresh this, hey, it's got my code. And
So,
then any of you could pull down my code now also.
so I had tried to do this before this meeting because I had finished a game. The problem I'm running into is that when I do it, it gives me the error that, let's see, what exactly does it say? Support for password authentication was removed on August 13th, 2021. Please
Yep.
use a personal access token instead.
Yep. So you got to set up SSH, and I think I've got instructions for that, but I will post them in chat.
Okay.
That is a solvable problem. And then let's say, like, don't do this, but let's say I wanted to edit this in GitHub. I could say, this was updated from GitHub. And then GitHub can like do the staging and committing and all that kind of stuff for me. So, all right. Now I made a change here. And if I make it, if I keep making changes on my computer, I don't have that change right now. So I could say something like, morning music was Robert Glasper. Okay, so I can keep making changes. I can stage my change, make another commit. Add music. All right, awesome. Now I want to push my new changes up to GitHub. Git push origin master. Oh no! It's telling me that GitHub has something that I don't. And it's like, you can't give GitHub new code until you've tried to take the code that GitHub has, work it into your code. So I go, all right, I want to pull, git pull origin master, and then it gives me that new code. And now I can push back up. Oops, git push origin master. And now if I refresh this, it's all there. That's Git in a nutshell. The things that I just did, remember how I mentioned that like, yeah, you can't do like a ton of things on the command line. You can do like 6 or 7 things, but they're the things that everybody knows how to do. The things I just did with Git are the things that everybody knows how to do. The stuff after that is kind of gravy.
Once you set your origin, do you like if you close the terminal, do you have to reset it next time, or is it just automatically? Okay.
Origin is a nickname now for GitHub. If I want to see all my nicknames, there they are.
Question.
Yeah.
So GitHub Desktop, because
Mhm.
I downloaded that and used that for my final project, and I
Mhm.
noticed that essentially when you made a change on the file that was connected to your GitHub repository, it would
Mhm.
translate and push that change to the to GitHub itself. So is this pretty much like what we're doing now? Is that we're just doing it manually?
Correct. You
Okay.
want control over that. Like, I'll give you a good example. So last night, when I was adding that new evaluation feature, I did that on a branch. So I went like get checkout branch um, some experiment. Cool. Well, now I can do all these experiments and stuff without having it automatically pushed to GitHub because I have the LMS set up to where when I push from GitHub, it deploys it. I don't necessarily want to deploy stuff that like might completely break the site. So you want like some control over when those pushes and pulls happen.
Gotcha. Thank you.
Yep. So you don't need to totally grok staging, committing, repos, any of that kind of stuff yet. I just wanted to give you a big picture target of where these pieces go. So with that in mind, what questions do you have?
This gives a lot of insight actually because when I was doing my website, I incorporated GIFs
Mm-hmm.
and the file sizes were too large to
Mm-hmm.
be uploaded through, like drag and drop.
Correct.
So basically everything you just showed, I had to do, and I was just following Google instructions, no
Yep.
idea what I was doing. But this makes a lot more sense as to what I actually did and how it worked with GitHub. So.
And check this out. So this is like I wouldn't even say it like most people, most devs are like even this, um, even that good at what I'm about to show you. But let's say I wanted to. Oh yeah, what was that? What did it say before it had this? I can do get checkout and then use my tab completion and go. What was it like 7 minutes ago? And I can check that out. It updates in real time. No, I want to get checkout. Not that one. Maybe. What was like this one? This first one I did. Like that. And then if I want to go back to where I was, get checkout master. That's pretty cool.
These lessons are going to teach us all this, right? Because
Yes.
I did not take in everything you said. Okay.
You were not meant to. All this is context. I'm showing you the whole map before you go out on the journey. So by the end of that get section, you should basically be able to do the thing that I just did. But you should not be able to do that already. Other high-level questions? All right. If you're still working on CLI stuff, keep working on CLI stuff. And then I'll probably do another Git thing once I've seen some submissions come through and just starting to get some people cranking on that. But elsewise, y'all are free until we come back from lunch. And I'm going to push that just a little bit today. So normally we're back at 12:30. Let's get back at 12:45 today.
And then
Elsewise,
where would you be posting the instructions?